Okay, so now we are going to solve practice problem 7.2 from Sadiku book. So the question is, if the switch in figure 7.10 opens at t is equal to 0, find Vt for t greater than 0 and the energy of the capacitor here at time 0. So whenever we have switch like this, it is usually to find out the initial conditions. So we will need to find the initial condition of V here, V0, and the initial condition is before t is equal to 0. Okay, so before t is equal to 0. So before t is equal to 0, the switch is equivalent to short circuit, right? So let's redraw the circuit. Okay, so we replace the switch with short circuit because it's still in the circuit. It will be open at t is equal to 0, but we will take a look when t is less than 0 here. So now this is a DC voltage source. Assuming that this is already in this condition, so the capacitor will be in the DC condition, which is equivalent to open circuit. So this one is assuming that this is at DC condition. Okay, so the capacitor will be replaced with an open circuit here. So we only have that resistance circuits, and then the V is here. So it is here, right? And it is parallel with this and parallel with this. So we can just use this one as our V here. Okay, now we have our ground here. And then I want to use KCL at node A. So we'll have KCL at node A. Okay, and I will assume that the current will going there. This is going there, and this is going there. So KCL said the sum of the current that goes in is equal to the sum of the current that goes out. Okay, now the current that goes in is this current here, which is 24 minus this one, VA, divided by 6, and that will equal to this one, VA, divided by 12, and then this one plus VA divided by 4. Okay, now I can just make all the denominator in the 12. So I will use this one, 48 minus VA divided by 12. And then this one will be VA divided by 12. And this one will be 3 VA divided by 12. Oh, sorry, this should be 2 VA. This should be 2 VA. And so we can cancel all this 12. Then we have 48 is equal to, I will move this 2 VA to the right hand side, so I will have 2 VA plus VA plus 3 VA. Okay, I will have 48 is equal to 6 VA, and VA is equal to 8 volt. And remember, VA is equal to V, so I will have VA is equal to 8. I mean phi is equal to 8 volt. So because this is our phi before t is equal to 0, I will symbolize that as phi 0 from the left is equal to 8 volt. Okay, now because our capacitor cannot change the voltage instantaneously, we will have V0 is still 8 volt. Okay, now let's save this because this is important value for our differential equations later. Okay, now our whiteboard is full. Let me clear this up. And now at t is equal to 0, the switch is turned open. So I will have after t is equal to 0. Okay, so after the switch turn open, our circuit will be without this 24 volt voltage source and 6 ohm resistor. So only the rightmost part. Okay, let's draw that circuit. So now I only have the capacitor and the 2 resistors here, and this is our V. Okay, now we can simplify the circuit. So we have 12 parallel with 4. So let's rewrite that, 12 parallel with 4, and that will equivalent to 12 multiplied by 4 divided by 12 plus 4, and this one will be 12 multiplied by 4 divided by 16. So this will cancel into 4, and 12 divided by 4 is 3 ohm. So we can replace this 2 resistor by a single resistor with the value of 3 ohm. Okay, now we have this value here is 3 ohm. Okay, now let's put this as our ground, and this node here will be our node. Let's name this node phi, right? Because the value is equal to phi. The voltage here will be phi, right? And then we assume the current will be going there to the node phi and going out from the node phi. Okay, let's do KCL at node phi. So KCL at node phi. Okay, now I will have current that pass through this capacitor, and remember that the current of the capacitor is C dV over dt. So I will have the value here 1 over 6 of C and then d over dt, and our current flows from ground to V, so I will have 0 minus V. And then this one will be the current that going out. So the current that goes in is equal to the current that goes out. So I will have V minus 0 here divided by 3. Okay, so now I want to isolate the V here. So I will have this one minus 1 over 6 dV over dt is equal to V over 3, and so I will have dV over dt is equal to, we can multiply both sides by 6, so I will have minus 2, right? Minus 2V. Okay, so we now have these differential equations, and this is our initial condition. Okay, let's solve that, but first we need to erase this. Okay, now I have these differential equations of first order, and this is the initial value problem. And so we can solve this by separating the variable. So I will move all the v to the left hand side and all the t to the right hand side. So I will have dv over v is equal to minus 2 dt, right? And then we can integrate both sides. So I will have this one and dt. We can put the integral here. So I will have dv over v, and that will become natural log of v. And this one will be minus 2t plus some constant. Okay. Now I will have v of t is equal to e to the minus 2t plus some constant, or we can rewrite this as vt is equal to e to the minus 2t e to the some constant. Okay, let's rename e to the some constant as a constant 1 maybe, because it is also a constant, so it does not matter. So I will have vt is equal to c1 e to the minus 2t. Okay, now our task is to find this c1 here, the value of c1. How? By using this one, v0 is 8-fold. So if v0 is 8-fold, it is when we plug 0 to this t. So I will have c1 e to the minus 2 multiplied by 0 is equal to 8. E to the 0 is equal to 1. So I will have c1 multiplied by 1 is equal to 8. And so c1 is 8. So our vt now becomes 8 e to the minus 2t. Okay, so we still need to find the energy. The energy at times is equal to 0, but we need to save this first. Okay, now lastly we need to find out the energy at time is equal to 0. So remember that energy is 1/2 c v squared, and because our c is in the time 0, so we will have v0 and this will be squared. So we can just plug the number 1/2 multiplied by the capacitance value, which is 1/6, and v0 is 8, so we'll have 8 and that will be squared. So I will have this one 1/12, right, multiplied by 64. So I will have this one divided by 4 and this one also divided by 4. I will have 3 and I will have 16. So 16 divided by 3 is 5.33, yeah, and so on. Okay, let's do 3 behind the points. So the unit is joule. So this is the energy stored in capacitor at time is equal to 0. So this is our answer. So this 2 is the answer for practice problem 7.2. So hopefully this will help you solving this problem. Thank you for watching. Do not forget to like and subscribe to my channel. Thank you.